For my Module 2 mini exam video, I will be examining the possible gamete types a Labradoodle that is heterozygous for chromosome number 8 can create. Labradoodles are a breed of dog that has been created as a hybrid from a poodle parent and a Labrador parent. There are many reasons people love the Labradoodle breed, with a specific trait coming to mind for me because I'm allergic to dogs is their trait of not shedding their coats, or at least shedding them at a lesser rate than other breeds. For the example in this video, I have deemed chromosome number 8 as having the 3 linked loci. These 3 loci are going to be coat type, hair type, and disposition, and you can see I have already drawn out the positions of 3 loci on the chromosome with coat type on the left, hair type in the middle, and disposition located on the right. The possible phenotypes for coat type are non-shedding being the dominant trait and shedding being the recessive. For hair type, we have curly hair being dominant over shaggy hair, and for disposition, we have outgoing as dominant over shy. I will be assessing my own dog, Ruby. Ruby's mother was pure breeding for non-shedding curly hair and a shy disposition, which as you can see allows me to draw out her chromosome number 8 as big S, big H, and little t from left to right. Ruby's father was pure breeding for shedding, shaggy hair, and an outgoing disposition, which we can see from his drawn-out chromosome being little s, little h, and big T from left to right. Seeing as Ruby's parents are each purebred homozygous, we can conclude Ruby to be heterozygous for all loci, as she received the opposite allele from each parent. I have drawn out her chromosomes so we can see her being big S, big H, and little t on the top, and being little s, little h, and big T on the bottom. I have drawn out a chart to calculate the probability of the 8 gamete types Ruby can create. The 4 different events that can occur on the chromosome to create gamete types is a double crossover, a single crossover at R1, a single crossover at R2, and no crossover at all. Before I explain the outcome, I would like to remind everyone that the coat type and hair type loci are 17 centimorgans apart, with the hair type and disposition being 13 centimorgans apart. I have also included the coefficient of coincidence value, which I placed at 0.7. I calculated the probability of the event of a double crossover by multiplying the 2 centimorgan values 0.17 and 0.13 with a C value of 0.7 to get a probability of 0.01547. I then multiplied that number by 1/2 to get 0.007735, which would be the probability of a specific gamete occurring from this event. Next, I calculated the event of a single crossover at R1 by simply subtracting 17 centimorgans from 0.01547, which was the probability of the double crossover event occurring that we had just found. The answer was 0.15453, which I then multiplied by 1/2 to get the probability of a specific gamete occurring from a single crossover event at R1. As you can see from the rest of the chart, I calculated the event of a single crossover at R2 to be 0.05725, and the event of no crossover at all to be 0.35774.